Okay, everybody. Well, welcome to Cloud Native at Scale. We're a meetup community based in San Francisco. For those of you who don't know, we have all kinds of people that show up. So where we talk about all things cloud native, from containers to service meshes, immutable infrastructure, microservices, declarative APIs, and everything in between. We're very excited to have our guest speaker today. But before we get to her, I'm Joshua Hurst. I'm one of the organizers at Cloud Native at Scale. Our host for this evening's event is Vijay Suryadevara. I hope I said that right, Vijay. She's a serial entrepreneur, and currently she's the Chief Product Officer and Head of Engineering at Fizzle. And you can go to fizzle.com if you want more information on that. But they are the first IoT solution to remotely operate multi-vendor particle counters and scientific data applications such as pharmaceutical manufacturing. Also, she is technical and business strategy advisor and mentor for startups and entrepreneurs, and is very active in the women IoT community. So, and not to mention, she's an expert in IoT. So we're definitely in good hands. And without further ado, Vijay, I will turn it over to you.
Thank you, Josh. Appreciate that kind introduction. And hello, everyone. I'm really happy to be here. Thank you for having me. It's a great opportunity for me to learn today. You know, very often we just talk in these events, and I love the events where it's very technical, where it's very hands-on and learning. And I love it even more when the main presenter is a woman. As you can see, I am partial to women in IoT.
She is definitely a woman.
No, I mean, in any case, I think it's just, it's wonderful when we are able to showcase the technical abilities of women and, you know, just talk about the kind of work we do. I think it's so important to bring that to the forefront. Our guest today is Kate Goldenring. She is a software engineer on the Edge OS team in Azure. She's a maintainer and core developer of Akri, an open source project that exposes IoT devices to Kubernetes clusters. I know that's the topic of our evening. At Microsoft, she specializes in security, IoT, and Kubernetes projects. So I'm really excited. I've had a chat with Kate. I think it's amazing the kind of work they're doing. It's early, but it's awesome, because I think when it's early, you can actually participate and really shape that and be part of the community. So I think I'm excited to learn more. So Kate, if you want to get started and just give us an overview of, you know, what Acry is and how you guys got started on this project.
Awesome. Thank you for the introduction, BG, and inviting me here, Josh, and everyone else at Cloud Native. And just to echo what you're saying, BG, I really love these meetups as an opportunity for everyone to share their knowledge and learn. And so throughout this presentation, feel free to drop any questions. I'm open to pausing and digging deeper anytime. And I do have a demo plan for the end. So hopefully we have time for that as well. I'm going to go ahead and share my screen. 1 second, I'm almost there. And all right, great. You should all see this pop up. Does that come up for you all?
Yep.
Yep.
Wonderful. So here's the title of our presentation. Today we're going to be talking about Ocry, which is an open source project that helps you discover and utilize IoT devices around your edge Kubernetes clusters. But in particular, we're going to focus in on how it builds off of Kubernetes concepts, and specifically the ability in Kubernetes to declare what resources you need for a workload to run, and how Ocry extends that concept so that you can request IoT devices for your workloads. So just a quick agenda overview. So we're going to level set and first start by talking about Kubernetes resources and how they're utilized. And then we're going to go beyond and talk about how the device plugin framework, when it was started a few years ago, extended that concept, allowing you to create your own extended resources for static hardware. And then we're going to go further and talk about how Ocry leverages the device plugin framework and brings it to the edge, where you have these IoT devices that are coming and going with intermittent availability, and the environment's less predictable than in the cloud, where the device plugin framework was intended to be used. And then finally, I'm going to demo using Ocry to discover some USB cameras, and we'll see an end application utilizing them. So to start, Kubernetes is powerfully declarative. When you create deployments, you can specify what resources must be available for a pod to be scheduled. And then the Kubernetes scheduler will make sure that those pods are only scheduled to nodes that have those resources available. So you can specify a requested CPU amount, memory amount, and the kubelet will make sure that that amount is available for it, and then it will evict pods that are running and using too much CPU and memory that you specified as a limit. So this is a really great way to know that your workloads are going to have everything they need to run and that they're not going to be using too many resources for your system. So an example deployment that does this model is right here. So let's say this is some random application deployment. You can see here that it has 3 replicas and we have 1 container. And we're specifying a resource request of, we need at least 76 megabytes of memory for this container, and we need at least 9 Kubernetes CPU units. That's very little CPU, that's 0.009 cores. So this is obviously a very small application in this example. And then we've specified some limits as well. And if you're curious about how might one go about deciding what the appropriate limits are for your application, there are some really great tools out there. As with everything Kubernetes, with such a large community, someone solved the problem. And so there's kubectl top, which you can run to see the current CPU and memory usage of your applications. And then you can also use the vertical pod autoscaler to automatically and dynamically adjust the resource requests and limits of your applications as they're running. So if you start to hit the upper bound limit, it'll automatically adjust for you. And you can also run it in a mode that doesn't automatically adjust over time. And that way it'll give you recommendations about what upper bounds and lower bounds you should set in your pod specs. So a great tool that I'd recommend, and you can even integrate it with Prometheus to get some beautiful graphs as usual. But obviously this is a great feature with Kubernetes, but what if instead of just requesting CPU and memory, let's say some application was an application that did some machine learning and it needed a GPU in order to process some images. What if you could say, hey, I also want 1 GPU. This workload can only be scheduled to a node that has a GPU, and you could just specify that here. Well, that is the problem that the device plugin framework aimed to solve. So here we can see that we have a Kubernetes cluster with 2 worker nodes. And you could create a device plugin by yourself that advertises this GPU resource as an extended resource to Kubernetes. That's what the device plugin framework allows you to do. It allows you to say some system hardware exists on this node that Kubernetes would have otherwise been unaware of. And then you could go ahead and schedule your pod and specify in it, hey, I want 1 GPU. And one thing to note here, this naming of this resource as GPU is just an example. When you create a device plugin, you decide what the name of that resource is. So most likely this would be more specific to the type of GPU you're using or whatever your device plugin wanted to decide to name it. But regardless, then when you applied this GPU pod, for example, it would be scheduled. It would successfully be scheduled to a node that had a GPU because you've set it exist on that node. One thing also to note about this image is that we have a device plugin running on each node, and these nodes look exactly the same. They both have 1 GPU, exactly named terms of hardware resources. They each have 1 GPU. And that makes a lot of sense because the device plugin framework was created with the cloud in mind. It was intended to be used on a bunch of servers that had the same static system hardware and had no dynamic changes happening there. You knew what was going to exist. But nowadays, a lot of things are happening on the edge, and these resources aren't necessarily embedded in the nodes. Rather, they're plugged into them, or they're on the same network as them. Think maybe you have like a USB thermometer or an IP camera on the same network as your nodes, or some industrial machinery. So how can we take this concept of the device plugin and apply it to the edge, where these devices are coming and going, and they're not embedded in the nodes themselves? And that is the solution that Acry aims to provide. So Ocry stands for Kubernetes Resource Interface for the exact reason of what I just mentioned. It really aims to be an interface just like the container networking interface abstracts away networking details from an operator. Acry aims to abstract away the details of discovering IoT devices and then creating extended resources to represent them using the device plugin framework. And then it can go one step further with its controller and automate the deployment of workloads to utilize those discovered devices. So it can also handle all the scenarios that are specific to the edge. So scaling up of devices, plugging in more devices, attaching them to the network, or bringing them down. It can also, the way it discovers devices is through its discovery handlers, which are oftentimes protocol implementations. And Ocry currently supports 3. So Ocry has a discovery handler for OPC UA for industrial settings, devices in industrial settings, for ONVIF for IP cameras, and a UDEV discovery handler for local devices. But Ocry was really made with extensibility in mind. It's a purely open source project, lives within Deis Labs with our other open source projects at Azure like Helm. And it really was intended to be something that a community can come together and make stronger. So creating a new discovery handler just means implementing our gRPC interface. You can write it in any language. It can run on its own. You don't need to fork Ocry. It's really supposed to be as easy as possible so that Ocry can support as many devices as possible. So we currently have 2 community members working on 2 new discovery handlers, a zero-conf discovery handler for MDNS-based devices, and a co-op discovery handler for constrained devices and constrained settings. And then a little fun fact about Ocry, it was built in Rust because we really are made for the edge. Ocry actually means edge in Greek. And so we wanted our components to be as low footprint as possible. But like I said, you can extend Ocry in any language of your choosing with our discovery handlers.
And in terms of the adoption of Acry itself, you're still quite young as a project, right?
Yeah, that's a really good clarification. So Acry was open source of October of last year. So we're very young, which like you mentioned earlier, VG, is exciting because that means that you can give your input and it might actually change the direction of Acry. We're really aiming to provide a solution, but if people think it would be provided in a different way better, like please let us know. In the last slide, I'll have a link to a section of our documentation. It's called proposals. It's purely where we would love for people to put their ideas. And you can put in a pull request with that proposal. We also have a HackMD to put your ideas, but we're definitely young and still in the evolution phase.
Sounds good.
Great. With that, I'm going to show our architecture. So Acry is Kubernetes native. It's made purely of Kubernetes components. The Acry controller runs in the control plane. The Acry agent runs on every worker node of a cluster, along with the discovery handlers that do the discovery on its behalf. And then we have 2 custom resource definitions. So the first one, Acry's configuration custom resource, is where you specify what you want Acry to find. And you do that by specifying what discovery handler should do the discovery. So if you want to discover IP cameras, you specify the ONVIF discovery handler. And in this configuration, you can also specify some filters that are specific to discovery handlers, which we don't show in this subset of it. But for example, for an IP camera, you could specify some filtering by IP address and scopes and MAC addresses. And also in configuration, you can specify a custom workload that you want deployed to each discovered device. We call this a broker. This is optional, but this is if you want to add that other part of Acry that automates the usage of these devices. So if you specify a custom broker, Acry will then deploy that broker to each discovered device. So once you've applied your configuration to the cluster, then the Acry agent will see it. It will see what discovery handler was specified and tell that discovery handler, start looking for those devices, whether attached to the nodes, across the network. And then for each device that discovery handler discovers, it'll tell the agent. And this is where the agent creates a device plugin to represent that specific device, thereby advertising it to the cluster as a resource. So then it can be requested and scheduled. And then the Acry agent also creates our second custom resource, the instance, which represents the device and its usage. So if 2 nodes can see that device, 2 nodes are listed there. It helps you keep an understanding of who can see it. And then finally, the controller will see that instance. And if you specified a broker, then the controller will deploy that broker to each, to the discovered device. And that broker has all the information it needs to connect to the device, because the way that the device plugin framework works is when you create a resource, you also specify what must be mounted in that pod. So for example, if it was a local camera, you would mount that dev node into it. And we also set environment variables with connection information. So for example, for an IP camera, this may be the RTSP URL for the IP camera that broker is supposed to interface with.
I have a quick question here, Kate.
Yeah.
When you first deploy your Acry Helm, do all the discovery handlers get deployed too? Or is it based on the configuration you did, the specific discovery handler gets deployed?
That's a good question. So when you deploy Ocry, you specify what discovery handlers you want deployed as well. And that's because you can later on add configurations. So say you deploy Ocry, the agent and controller, and you also specify you want the UDEV discovery handler deployed, you can later on then apply a configuration. We have thought about automating the deployment of discovery handler once it's specified in a configuration, which is, like you brought up, that would also make it easier. You wouldn't have to think about what discovery handler you want. It would do it if you request it.
Okay. Looks like one of our participants is interested in asking a question. If you could just type it into the chat or Q&A. I see it's in the Q&A.
Yeah.
I'm going to read it out. It's a little long, but I'm going to read it out for you, Kate. When the pod spec asks for a resource, the pod does not spawn till the resource is available. So the assumption seems to be that the IoT device is present and reachable when the pod spawns. Is there a way for the pod to spawn and wait for the IoT device to come online? I guess it's a chicken and egg question, right? Can you start the discovery handler before the device is there? I would assume so, right? That you turn that on and it keeps scanning for devices, and as and when a new one gets plugged in, it'll get discovered? Or does the device have to be plugged in before you can actually spawn the discovery handler?
So the discovery handlers can be deployed before or after the device is attached to the network. It doesn't matter at what order. You can continue to attach more devices. Also, this question is asking about, can a pod request a resource for a device that is not yet online? The answer to that is no. The Acry will not create a resource that is requestable unless the device is visible. We need to be able to connect to it in order to say that it exists. So an IP camera will not be requestable until it comes online, if that also answers that question.
Yeah.
And then I thought I saw someone ask about what language Acry is built in. So the controller, agent, and our current 3 discovery handlers are all built in Rust, but future discovery handlers can be built in any language of your choosing. Your custom brokers, of course, because they're a pod, can be written in any language of your choosing as well. And that is where you decide what goes there.
Okay, sounds good.
To show the flow of using Acry, I have a flow diagram here. And the scenario I want to talk through here is you want to discover some IP cameras because you have some end application that wants to do something with all the frames. Maybe it's doing some ML processing. Maybe it's just streaming all the frames from it so that you can see them all in one view. So first thing you do is you set up your cluster. In this case, we have a control plane node and 2 worker nodes. And the next thing you need to do is deploy your application that's going to benefit from the work that Acry is doing. So in this case, I just called it custom application. It does what I mentioned before. It could be any number of things, but it wants these frames from these IP cameras that we're going to discover. So now, and this custom application has been pre-configured to point to a service that will automatically be created by Acry to grab frames from all of our brokers that will be deployed. So Acry can also automate the deployment of services upon discovery of devices as well, services for individual devices and for all devices of a configuration. So now that we have our custom application deployed, we can go ahead and deploy Acry using our Helm chart. This one Helm installation deploys it all to our cluster. We can see from our previous architecture diagram, our controllers running in the control plane, our agents are on each node, which is, remember, that device plugin component. And then our discovery handler, in this case, in our Helm chart, we specified we wanted to use the OnVIF discovery handler, so that's being deployed to each node. And now that we have Acry deployed to our cluster, we can go ahead and apply a configuration that will kick off discovery. And this could have been done with the previous step as well. So in our discovery handler, we're specifying we want to discover IP cameras by specifying the OnVIF discovery handler. We're not specifying any filters here, so we're going to discover all of them. And we're specifying a custom broker. In this scenario, we'll say this is a frame server. So all this broker does is it'll connect to the individual device, and it will grab the frames from that camera and serve it over some gRPC interface so that our one service can aggregate all those frames. And then the last thing to note about this configuration is this capacity setting. That's where you tell Ocry how many nodes are allowed to utilize a single device at once. So we're setting this to 1, meaning a broker is only going to be deployed to 1 node at a time to utilize a device. So now that we've applied this configuration, our agent will see it and tell the OnVIF discovery handler, hey, start looking across the network for any IP cameras. So we don't see any in this diagram. So let's go ahead and plug one in. This could have been done at any point. This could have been before installing Acry. You can continue to plug in more, but let's say you do it now. The discovery handler will see it, tell the agent will create a device plugin to represent it, and we now have an instance to represent this camera. So then the controller sees that instance, it goes ahead and deploys a broker to 1 node because we specified a capacity of 1. It creates a service for all of the cameras and all of the brokers that are discovered. And now our custom application is receiving frames from that camera and doing the work it was intended to do. However, we're on the edge. Things can be unpredictable. So let's say that a node went down. Since our other node also said that it could see this camera, our controller will automatically reschedule that workload. However, there was a little bit of downtime there where the custom application wasn't receiving any frames. So if we had specified from the start a capacity of 2, then the controller would have deployed a broker to both nodes from the start, so that if one node went down, you still had one grabbing frames from the cameras and a more highly available scenario occurred.
I have a question here, I think, Kate. It's really interesting to see that you could have 2 agents discovering the same camera, for example. So I would assume there's only one instance created, one instance CRD. Does it have multiple entries for all the agents that can access this particular resource?
Yes, exactly. Okay. So there's one instance for this IP camera, and then within our instance, I can show you when I demo, we have a nodes section of it, where that's a list of all the nodes that can see it. If capacity is set to 1, that means that the device plugin that Acry creates to represent this device only has 1 entry. So when Kubelet requests that resource for a pod, it takes that 1 entry for that node. So then when the other node tries to request that one camera, the kubelet will say, sorry, taken. Or the agent will tell kubelet, sorry, taken. And so that broker will not be able to be scheduled to the other node. However, if you up the capacity, that allows more nodes to request this resource.
Yeah, sounds good.
Great. And all that flow that we just saw can be kicked off with one Helm installation. So you'll see here, we specify that we want to use OnVIF for the discovery handler. You can specify your broker. In our case, that was that frame server we talked about. And then finally, you can specify that capacity. And like every Helm chart, there's obviously way more details that you can go into customizing your installation. But it is great to see that you can just do it in one installation. And with that, I was going to go ahead and do a demo. Before I do that, are there any other questions, or would people prefer to ask after the demo?
I have one question, Kate.
Yeah.
Is there because these are running mostly on the edge, we might expect like running more than one instances of these Kubernetes clusters, right? Is there any aggregator in the Acry itself to get a overall federated view? I don't know if that makes sense.
Are you saying having multiple, having Acry deployed as multiple tenants within your clusters?
Yeah, like in multiple clusters, and then have a single view.
Yeah, so you can definitely deploy Acry to several clusters from one spot. Say if you use any cloud Kubernetes manager for your edge deployments, that's certainly an option. You can't have 2 agents running on the same node because they are because they're creating device plugins for it doesn't make sense to have multiple agents running on the same node because they would be trying to create multiple device plugins. So there might be issues there, but you can certainly deploy Acry to multiple clusters.
I think there's another question which is asking what kind of devices are compatible with Acry. I think it really depends on the protocols being supported. I think you mentioned 3, right? Maybe
Exactly.
over them again. Yeah.
Yeah, so just to go over those again, we currently support OPC-UA, which is a common protocol for industrial devices. So we can discover OPC-UA servers and applications. We also support ONVIF, which is a common protocol for IP camera communication. And then finally, we discover UDEV for devices in the Linux device file system. So that can be anything within your dev directory. So pretty much anything you plug in through your USB. And also like embedded hardware, such as GPUs, for example. Ocry does support all of the normal device plugin scenarios, so like GPUs, TPMs, etc. But if you're interested in supporting a different protocol, my next slide kind of points you to Acry. We have our new extensibility model that I mentioned at the beginning. So you can certainly create a new discovery handler, say for Bluetooth devices or LoRaWAN or whatever communication protocol your devices speak.
Yeah, I think demo will be great now. So
awesome. Can you see my terminal here?
Yes.
Yep.
Wonderful. Let me just make sure we're all connected. Wonderful. And so the demo I'm doing, I also will say we have in Ocry's GitHub. So if you ever want to, after this, if you're excited and you want to start using Acry, the next slide will link you there so that you can run this yourself. But to start, let's look at our cluster here. So we have a 2-node cluster. Both are, we're using Micro K8s and Kubernetes version 1.20. And so the next thing we're going to do is we're going to check, and in this demo, we're going to discover some USB cameras. So this Brytel server has an actual camera plugged into it. This server that I'm currently on has none. So we're going to go ahead and mock some. I already set up the mocking for them. We can look and see that we have 2 cameras plugged in to this node. But I'm going to go ahead and use GStreamer to pass some footage through them. One is just a ball moving around, and the other is an SMTP color block that's moving. And I have a script just for doing that. Oops. So we should have some frames passing through these cameras now. So now that our cameras are all plugged into our nodes, let's go ahead and install Acry. So the first thing you do when you install Acry is you need to pull down its Helm chart. I've already done that for my notes, so it already exists. Another thing you need to do is, because Acry uses CRI-CTL, because we need to query the container runtime to see if brokers that are using resources no longer exist. The reason we need to do this is because the device plugin framework doesn't yet support a deallocate scenario where you tell kubelet, I no longer am using this resource. There's a PR in the works to fix that, but for now we have a workaround which includes querying CRI-CTL. So for Micro K8s, I'm just passing Acry the location of that. And then we're ready to go ahead and install Acry. So let's look at our Helm installation command here. We're saying that we want to deploy the UDEV discovery handler here. We're saying we want to deploy a configuration specifying the UDEV discovery handler. We're also putting a name to it because there's a lot of things in Linux device file system. So maybe I'm later applying a configuration to discover microphones. And so I want to know which configuration's which. So I'm specifying we're specifically finding video cameras here. And then the way the UDEV discovery handler works is you pass it some filters as UDEV rules. So you don't want to find everything, all of your devices. Specifically, we want to find video devices. So I'm passing this UDEV rule here to tell our discovery handler what exactly to find. And then finally, for this demo, we've created a custom broker. And what this does is exactly what we walk through in the flow, it'll connect to the individual device, grab the frames and serve them over a gRPC interface. So now that we have our installation command, we can go ahead and install Acry and watch as everything comes up. So you can see here that we have an agent being deployed to each of our worker nodes here. One of our nodes is acting as both a control plane node and a worker node, so it also has a controller deployed to it. And then you can see that 3 cameras were discovered. We had 1 real camera on that Brightel server, and then 2 mock cameras that we saw setting up on our local one. And so an instance was created for each of those. And then we have our configuration that we applied down here. And we remember we named it Ocry UW video. And then because we discovered 3 cameras and we specified that broker image, we have our broker pod automatically spun up for each of them. So everything's up and running, but this is kind of hard to see. So we'll deploy a streaming application to visualize and see all these frames that Acry has discovered. But before we do that, let's go ahead and look at this instance since we talked about it a little earlier. I just picked one of them so we can see. So you can see here inside the instance, that nodes list that I talked about earlier, because this is local, it's not a shared device. The only node that can see it is the one it's plugged into, so Uriel Linux. And then because we set capacity to 1, that's the default, we have 1 entry for using this device, and Uriel Linux has requested it. And then finally, we have this broker property setting, and that's all the environment variables that are going to be injected into each of the broker pods so that they know which camera to interface with.
And environment variables are configurable based on the kind of protocol you're working with and the kind of broker requirements and so on.
Exactly. The environment variables are specified they're correlated with the discovery handler. So the UW discovery handler always sets a UW dev node environment variable. The OnVIF one always sets different ones. So an RTSP URL endpoint. And you can pass additional environment variables to your brokers via your configuration. So say for video, you wanted like say you wanted to specify like the frame rate. You could do that in your configuration so that all your brokers know that as well. Wonderful. So let's go ahead and deploy a streaming application so we can see all this. And this is going to point to the one configuration service that Acry created. Let's actually look at that. So I mentioned earlier that Acry can automate the deployment of services. So since we didn't specify otherwise, Acry created a service for each of our broker pods and one for all of them, this aggregate service here, which is what our streaming application that I just applied is pointing to. So let's see if it's up and running. Awesome, it is. And let's go ahead and grab the port that it's running on so we can port forward to see it. Wonderful. And
now the magic happens.
Yeah. Wonderful. Okay, so we have our 2 mock cameras and then our one that's looking at the floor of my manager's office. Thank you, Brian. So this looks exciting. Here we have, so the streaming application, I said how it's pointing to that one main service. That's this one. So it's round robining, pulling frames from that one main service, Kubernetes service Acry created. And then it's also pulling frames from each of the individual services Acry created. So things are dynamic. People build out their deployments. So let's go ahead and add an additional camera. So I'm going to go ahead and mock that. Oops, I already. Awesome. So we just added an additional camera here. If we watch, we should see another one pop up in a second. There we go. We have another instance for this other video. Another broker is being automatically deployed. Now it's running. So our streaming application has now updated to include it. So now we have 4 cameras, and that was all dynamic. All you had to do is install Acry from the start, and then you can now scale out your IoT deployments, and Acry will handle it. So that's the demo I have for you all. While I have Acry running, I can go ahead and break it down. All you have to do to get rid of Acry is say you wanted to stop discovery of USB cameras, you can just delete that configuration.
And if we disconnect or remove one of these devices, it will automatically remove the instance CRD that got created for that particular one?
Exactly. So that bring up scenario that we just saw is exactly identical to the bring down scenario. So if we had removed a dev node, which I can't do because I'm not in my manager's office and the kernel module that I'm using won't let you unplug if it's in use, which it is by our GStreamer and our broker, I can't show that, but it would be the same thing. So Ocry's discovery handler, which the UDEV one pulls every 10 seconds, would notice, hey, something changed. This device that I thought was there is no longer there. I'm going to go ahead and tell the agent. So the agent sits there. It's a push communication style. So the discovery handler just updates the agent whenever something changes. And so then the agent would know, oh, this device no longer exists, deletes the device plugin that advertised it, deletes the instance, controller sees the instance is gone, deletes the broker, the services, and it's all cleaned up for you. And a similar scenario happens when you delete a configuration. The agent will see, oh, that configuration was deleted. I'm going to delete all those instances. They're all now gone. The configuration is gone. It deletes the services. And then we'll be back. We still have our streaming application, so it's probably not happy. We'll be back to a scenario where now you're ready to apply more configurations if you want, apply more discovery handlers, whatever suits your needs.
And when, it's a very common thing in edge computing that the device connectivity is very unpredictable, where the devices are disconnected, but doesn't mean they're gone. So what is the threshold at which, the discovery handler says this device is gone for good? And is that threshold configurable?
Yeah, exactly. That's a good question. So it depends on the type of device. So for local devices like USB cameras, if we can't see that device, if the discovery handler can no longer see it, we immediately mark it as offline, delete the instances. However, for shared devices and network-based devices like IP cameras and OPC-way devices, if it's no longer visible, we give it a 5-minute grace period.
Nice.
However, that is not currently configurable. That's on our issues list and should be configurable because say you want a longer grace period because your devices tend to be offline for longer periods of time or a shorter grace period, that's definitely something we should implement soon.
Sounds good. Yeah, I mean, that's something in IoT, that's absolutely one of the major requirements. So it's great that you guys are already working on it. So if anybody has any questions, please do ask. I have a few more. Otherwise, I'll keep knocking off one after another of my own questions. But anyone has questions, please feel free to post. Kate, do you have anything else that you would like to go through before we?
The only slide I have left is how you can get involved, how you can learn more. And I'll leave this up as we continue to discuss in case people want to check this out. But that demo that I just ran through, you can do it yourself. We walk through how to set up your cluster, whether with Kubernetes, K3s, or microgates. If you use something else, give it a try. Let us know how it goes. We've tried on K0s and it went okay. Like it worked, but we haven't tried more than once. So if there's any other kind of Kubernetes distribution you use, feel free to give it a try. We have our documentation. We have an Ocry channel on the Kubernetes Slack, that proposals section I talked about earlier. And then, of course, how you can contribute. The question earlier about what devices can we support. If we don't support it, we'd love your help in supporting it. And the only other thing I would say is we are going to be at KubeCon. So just a week from tomorrow, we have a main session. It's similar to this talk. What you're going to get there that you didn't get here is more of a discussion of what works today. So we start out the presentation by talking about solutions that already exist that Acry simplify. But the latter half is very similar to this presentation. So it might be good to at least jump into the first half of it. And we also have a lightning talk that's just 10 minutes that talks more about what motivated Acry. And specifically, that was the question of where can Kubernetes run? That was the question my team was trying to figure out. We have all these optimizations of things like K3s that allow Kubernetes to run on really small devices, but then you have these MCU class devices like that have this single fixed function that cannot fit Kubernetes. And so that's where Acry stepped in as the solution to how to utilize them.
Sounds good. I have a couple of more things I certainly can go over. One of the things that I found interesting is the fact that not only are you discovering and declaring the devices with the instance CRDs, you're also actually initializing or deploying the brokers that can actually work with that particular device. So, and then the service on top of it. And so the consuming application can then start working with that resource and start using it. But in your examples that you have shown, it seems to be a very tight coupling with one edge device with one broker or more but is it possible for one broker to handle many devices? Is that even conceptually something you're working on? Because that's typically what happens in IoT systems. Because we have hundreds, if not thousands of devices that we work with, and sometimes even much larger scale. If you're looking at smart cities or, and to try to deploy one broker per device is impossible. That's not a realistic scenario. So I just wanted to see where you guys are in the thought process around what is configurable, how are you configuring it, and what you're thinking about it. So
yeah, so the way we handle broker deployment to device is something we call our broker deployment strategies. And like you mentioned, we currently have one, and that's this microservice approach of one broker to one device. And like you mentioned, that does not fit most of people's scenarios. So we're definitely working on providing more. We have a proposal up for several. We call one instance pooling, where you have one broker deployed to multiple devices of the same type. So say why not have one broker interface with 4 IP cameras and serve as a frame server instead of having one to each? That makes sense. Or resource pooling is another one where maybe you have that end application that we talked about in our scenario. What if that was automatically deployed to 4 cameras and 1 GPU? And so those are 2 broker deployment strategies that we're definitely, that's on our horizon, it's on our roadmap, and definitely something that we would like to work on as soon as possible. But we also would love to hear if there are other ones. So if those 2 don't fit your scenario, I would definitely be curious to hear about the strategy that would work for you.
Yeah, I mean, there's so much, right? I mean, there's so much to unpack, like we say. IoT is such a complex environment because of the heterogeneous nature of the devices, the various protocols that are available, the different levels of control you can have on the devices. Some are just kind of streaming, like the one that you just, the example you showed was a streaming application. So it's pretty much like a stateless device interaction, right? So whether the device goes down, comes back up, it doesn't really matter. You're deleting that instance and creating another one for the same device. And I'm assuming you are expecting, if it is a stateful kind of interaction with a device where you're doing something with it and you want to see what happened to what I asked you to do last time, then you're expecting the consuming or the application, the customer application, or I think you call it custom application. You're expecting that one to maintain that stateful information about where, I mean, this is the same one, even though it's a new instance CRD, but it's the same instance as it represents the same resource. Let's put it that way. It's a different instance, but it represents the same resource. And so I can pick up where I left off. So I think that's another huge requirement in most IoT scenarios. I don't know if you guys are looking into that or thinking about that at all.
Are you saying the requirement of who does the work of maintaining the state?
Yeah, so essentially like all you've shown today is primarily assuming that you can connect to a device and disconnect and this doesn't matter, right? It's basically you're just consuming something from the device. It's like a monitoring scenario. It's like a streaming scenario. It's not an interactive scenario where you're actually asking it to do something. Right. Suppose you have some kind of device which automates closing a door, right? And then you ask the device to close the door, and then you've lost connectivity in the meantime, and that resource has been, scaled down. and now it comes back up after 5 minutes. And you want to know what happened. Last time I asked you to close the door. Is it closed or not closed, right? So there's a lot of stateful interaction that happens with IoT devices, not just stateless interactions. But I think the way it is structured right now, what the demo you showed was very much focused on kind of stateless, you can disconnect, connect back, it doesn't really matter.
That's really interesting. That would definitely be a place where we obviously can put some more thought. And I wonder if one strategy to that would be maintaining those brokers or custom workloads, like keeping them running so that they can maintain state. So like you mentioned, if the device goes away, and so then we lose connectivity with it. So then the broker that was controlling the response and work of the door or monitoring it then was brought down as well. Immediately, that obviously we lost all information, but maybe if it was maintained for some reason by Ocry, so that instances are brought down, but the associated brokers stay, that might be one solution.
So in our architecture, because we do IoT, we use Kubernetes too, but we don't use Akri. It's of course new, but we do have discovery. We have similar concepts because these are something that happens all the time. We have agents and handlers that are running on edge gateways and are finding devices and kind of connecting them. And then we have more process because we cannot let any device come on board. So we have a lot of security around it as to what is allowed to become available as a resource and to whom and so on. I think that's one aspect we can certainly touch, and maybe you can talk about some of the security pieces around it. But there is that whole, you can handle statefulness anywhere. It could be in the broker, it could be in the custom application too, for sure. I'm just curious if you guys are thinking about it at all. So yeah.
Yeah, I think if anything, we're now thinking about it a lot more. So that's definitely something that we should have a proposal about.
That's awesome. And then the security part of it, I think we spoke about it earlier too when we spoke when we first met. Again, a lot of this is assuming there is no authentication authorization around, which application can use which resource. Is there any such framework that you're thinking about, or is that all going to be managed in that custom broker that is created to interact with the resource?
Yeah, so that is the question: is should the discovery handler, should its job just to be able to ping that public interface of a shared device and say, hey, this existed, and it's up to the broker to then authenticate? That is one question, and that is Ocry's current approach, and it does help with that in the sense for OPC UA, for example, it does for the OPC UA server, it has a shared root certificate. We pass a child certificate into that broker so that it can then authenticate with that device because there's that shared root. But if that's not the authentication pattern, we haven't found a framework for it yet. And for example, with IP cameras that have user password-based authentication for each camera, the solution to that may be a config map of sorts where you can store user password pairs, and then the broker can be granted access to that and grab the credential. But that is definitely an area where we are looking to security experts in the community to give their thought, especially in the IoT space, like you all, and share their learnings and what is the best scenario for them. And also hear about the authentication scenarios they're using, what kind of authentication and how frequently are they rotating, and
right.
How long are they allowing devices to be connected to. Scenarios like that we would love to hear from the community.
Yeah, I mean, there's so much that goes with security, right? On the one hand, IoT is all about making it easy to discover and find devices and access them and work with them. But on the other hand, that also means somebody can look into your child's room with their baby monitor, right? So it's all about kind of controlling while providing access. And like you were mentioning, I think there's so many scenarios. It's not just about authentication, but also location-based or time-based authentication. Like if the person is working on the floor, they're allowed to have access to these things. But if they leave the office or they're not working anymore at that point, they should not have access and so on. So there's so many layers to that. I think we can have another whole session about security and IoT. But it's great that you guys are already putting a lot of thought into how to build this. And like you said, it's a great opportunity for companies and people like us to come in and say, hey, we should do this and kind of help and build that piece. So
definitely, yeah.
Awesome. Yeah.
Yeah, definitely on that note, Acry is really interested in building partnerships and working with community members. And so, yeah, if, like VG, you're pointing out great areas of improvement. And if that's something that folks have an idea of the solution, that's definitely where you can play a part in developing this young project.
That's awesome. I think so far it's so impressive. I love the fact that it's very modular. I mean, of course, it's microservices. Obviously, it's modular, but the fact that you guys have made it in such a way that you can extend it by just adding more discovery handlers, and the rest of the framework is already there. I think that's pretty neat. I don't know if anybody else has any other questions.
I have a question. So what's the goal for the project? Are you trying to get it into the CNCF, or what's the vision? How do you think about that?
Yeah, definitely. We want it to be community governed, whether CNCF or otherwise. We're not sure exactly where it lands because it is so young. So the body that governs it, it should be aligned with its goals and where it fits. So time to be shown on that, but we certainly want to get those partnerships in order to get it to a place where it can be community governed.
Awesome.
And
So
how big is I'm sorry.
no, you go.
I was just going to ask that, how big is the contributor community right now? How big is the project?
Yeah, we currently have, I guess if you were to look at GitHub, 15 contributors. They're kind of from all over. We've had people from Alibaba contribute. We've had some open source developers who enjoy like contributing their free time. And then we also have a lot of researchers involved because you have a lot of manufacturing researchers who are trying to access and get a lot of data from a bunch of different devices. And so they've been interested as well.
Very nice.
So is that from industry, these researchers?
Yeah, a little bit of both.
Yeah.
Industry, also government-backed projects. Yeah.
Cool. So what's Microsoft's interest and how are they supporting this project?
Definitely. I think Microsoft's interested in Kubernetes as a powerful solution, in particular on the edge. That's also where we're focusing into. And Ocry, if it can make Kubernetes more powerful on the edge, it can make Kubernetes a more approachable solution to everyone. And so that's why it really is community oriented, because the more people we can get contributing discovery handlers, the more powerful it is and the more people it brings to Kubernetes.
Awesome. Awesome. So what's the best way to follow you? Social media, LinkedIn, Twitter?
Yeah, I would say Twitter. It's just my first name and last name. I can pop it in the chat right now. Feel free to reach out there. And then we also have an Acry Twitter. So we have been putting some updates there. I'll go ahead and drop that. And then I would say if you're interested in Acry, definitely join our Slack channel and ask any questions. And if you don't feel comfortable putting a message out there, I know I wasn't at first, you can direct message me and I can aim to answer your question or point you to someone who can.
Awesome. Awesome. VG, is there anything else? Did you have anything to say?
No, I think it's awesome and I love it, the work you guys are doing. It's such a young project, but you already achieved so much and a lot of thought went into that. So I'm hoping that we all can contribute and make it bigger.
Awesome. Can you guys see my screen?
I can, yeah.
Okay. So I just wanted to invite people to, whoops. This is our meetup here. So Cloud Native at Scale, you can find us there. And this is our next event. So I just wanted to put that out there. Melinda Liu, who's working at a stealth company. And so events first, Cloud Native Patterns Beyond Request and Response. And that's going to be on May 11th. And we hope to see everybody there. So thank you, Kate, so much. Really appreciate you sharing your work. And VG, thank you. You're a fantastic host. I hope you come back, join us. Can you say yes? No.
Absolutely, Josh. I think you guys are doing some good stuff, so we would certainly like to participate. And Fizzle is based out of San Francisco, and we use Kubernetes as our basis of our whole product. So we are always interested, and we are an edge IoT company. So a lot of this work we are already doing. So if there's some way for us to be part of this community, we would love that.
Awesome. Thank you, everybody. Thank you, Chakri, Vasu, everybody.
Thanks, Kate.
All right, Kate. Thank you so much, Kate. We'll be in touch.
Thank you, everyone.
Bye.
Okay. Bye.
Bye.
See you, Chakri. All right.